All right, boys and girls, here we are. First lesson of the unit, which is talking about 1.01, simplifying roots and imaginary numbers. Some of this stuff you're going to get, some of this stuff you're going to have some trouble with. Before we start anything, I want to make sure that we're all on the same page with perfect square roots. We need to understand perfect squares. To understand perfect squares, you simply multiply the same number by itself. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. These right here are considered perfect squares. Spell. Not English class. Perfect squares. Those red pens got to go. That's done. All right, all of those are considered perfect squares down that side. So when we look at this stuff, we want to know what are perfect squares. So for right now, if we look, the square root of 16, the square root of 16 is a perfect square. The reason it's a perfect square is because when you have the square root of 16 can be written as 4 times 4. Which you can separate this if you want. I'm going to go deeper. This could be the square root of 4 times the square root of 4. Well, the square root of 4 is 2 times 2, which equals 4. That's the whole totality of it. You can either understand that the square root of 16 is 4 because it's multiplied by itself. You can separate them, understand that the square root of 4 is 2 because it's multiplied inside, and then that's how 2 times 2 is 4. That's the reasoning behind why the square root of 16 is 4. Now, when we get further into this, we're going to need to understand that these are going to be, when we take the square root of a number, will be positive and negative. But for today's purposes and where we start, we don't need to necessarily do that. Technically, when you take the square root of something, you're dealing with positives and negatives. Positive and negative. Particularly when we start graphing quadratics. And at the end of the day, all this stuff we're doing is going to be based upon us being able to graph it. It has to graphically make sense. The reason for imaginary numbers is that graphically they appear. Algebraically, within the number system, they don't make sense. So they had to, if you think about it, they had to be created because they actually appeared graphically, but algebraically, they didn't make any sense. Hence their creation, hence the name imaginary. If we look at square root of 81, we'll notice it there. So technically, the answer to this is positive, negative 9. For our intensive purposes, you can just write 9 for what we're doing now because we're not graphing it. The reason it's 9 is because the square root of 81 can be the square root of 9 times 9, which is the square root of 9 times 9, which is 3 times 3, which is 9. That's how all of this stuff works algebraically. When we start talking about algebra, a lot of times we go, oh, square root of 81 is 9. Why? That's why. That's why, as a whole, you can split it up inside. Then once they're inside the houses, if you will, you can separate them. And then the square root of 9 is 3, and so forth. Now, when we get to number 3, square root of 12 is not in here. That's in between 9 and 16, but there's no number that I can multiply by itself that gives me the square root of 12. So we have to split it up. And that's why I show you this split up system here originally, because it makes sense now. we can go the square root of 12 can be 4 times 3. Well, we'll notice that 4 is right there. So now we can split that up as square root of 4 times the square root of 3. Well, the square root of 4 is 2. Square root of 3 is the square root of 3. For purposes of what we're doing today, it's just positive. However, when we get into graphing, you're going to need to know that it's positive and negative. Not yet, but you will need to know that it's positive and negative. And we'll talk more about that as we go along. For number 4, we've got to break this down a little bit. For me, how I would like to break it down, because it's going to be impossible for you guys to see this without breaking it. First, you divide 180 by 2. 180 divided by 2 is 90. So 2 times 90 equals 180. 90 divided by 2 is 45, because 2 times 45 is 90. I can't divide 45 by 2, but I'm going to divide it by 3. 45 divided by 3 is 15. 15, I can't divide by 2. Divided by 3 is 5. So now I have all of these numbers. If I look at these two, I have 2 times 2 is 4. 3 times 3 is 9. Multiply these two, 36. So now, and then I have also the additional 5 that's left over. So now, the square root of 180 can be rewritten as 36 times 5. 36 times 5 equals 180. This can be separated. And the square root of 36 is right there. 6 times 6. And there's your answer. It may take some of you guys some time to break that apart, or you could use a calculator. You're at home. This calculator here is the money one. This is the one you want. Does a lot of stuff for you. All right, this here has 2 parts. So while we don't touch this part, we leave it. This is considered a complex number. It's not an imaginary number, but it's a complex number. Okay? So 2 we just leave here. We're going to leave that there and the positive. Okay? We got to separate square root of 54. So the square root of 54 can be broken down. 54, since it's even, divided by 2 is 27. 27 is not even, so we divide it by 3, gives me 9. All right? Once I see that I have a perfect squared number, you can stop. Knowing those perfect squares are important. 3 times 2 is 6. So now we have these 2 numbers. This can be rewritten as 9 times 6, which can then be separated. 9 times square root of 6. Square root of 9 is 3. 2 plus 3 square roots of 9. And this is the reason why we don't do a lot of the positive negatives right now, because we can't. It's already positive. This determines the sign. It's already there. Complex number. Some parts stay inside that can't simplify. Some parts that are perfect squares can't simplify and come out. Okay? That's the first part. So we're going to erase this. Move on to the next part as we start to introduce the eyes. Let me get my, oh, yeah. Let me see something real quick. Let me split this stuff apart a little bit. it's separated. Okay? Awesome. All right, the imaginary number I is represented. Okay, so we need to talk about this. The imaginary number I will be represented as I will equal the square root of -1. That is what I equals. Square root of -1. Now, if you plug that into your calculator, if you had this calculator and you hit second, this button which has the x squared gives me a square root, the negative button, and then 1. So I have the square root of -1, and you hit enter, it will say domain error. The reason it says domain error is because it's imaginary. Algebraically, it does not make any sense. So, how can we make sense of it? Well, we're going to use some tools that we're going to talk about. So it says, what happens if we raise I to the second power? What that is saying is, what happens if we square the I? Okay? So if we do something, this is an equation. If we do something to one side, we have to do it to the other. Okay? So what happens if we square the I or raise the I? Well, now on this side, we attain I squared. So what happens to our square root of -1 squared? Well, if you don't remember how to handle this, anytime you square a square root, it simply cancels it out. So what that's saying is this would be the square root of -1 times the square root of -1. Which would basically mean that it cancels it out. Very similar to how we had before. Remember when we had this, right? Then you had this. We just did this up above, which then we end up with that. So you end up, when you square it, you end up with -1. So while I equals the square root of -1, I equals the square root of -1, I squared equals -1. Okay? I'm going to give you the cycle of I, which you're going to find very important as we go through this. I'm going to give it to you. You don't have to have it. You just need to understand the first two, which is I to the first equals I. Okay? Even though it equals -1, it still equals I. It's imaginary. I squared equals -1. These are the two that you're going to really need to understand. The next ones will be I to the 3, and that equals -I. And I to the 4, which equals 1. I'm not sure if we're going to do these just yet, but if we do, we're going to need to know them. We're going to deal with this because if we think of it in these terms, I to the 3 equals I squared times I1. I squared equals -1. I to the 1 equals I. -1 times I equals -I. Okay? Same thing here. And that's why that equals 1. Not sure if we're going to go down that road yet, but if we do, you got it. Definitely going to need to know the purple. The green we'll talk about as we go forward. Real numbers. All real numbers could be 2 square root of 6, 12 square roots of 3, 15 square roots of 2. All of these are considered real numbers. Imaginary numbers, square root of 10. Square root of square root of negative 10. Square root of negative 4. Square root of negative 9. Even though they're perfect squares, the reason why these are imaginary numbers, the reason why these two in particular are imaginary numbers. So remember that the square root of 4 equals 2. Remember that? Because square root of 4 equals 2 times 2. Right? That's why it equals 2. The problem with negative 4 is that you'd have to have negative 2 times 2. And negative 2 times 2 is not the same number. Here you have 2 times 2. That's why 2 comes out. Here you have negative 2 times 2. 2 can't come out. Okay? So we're going to get more and more into this, but hopefully you understand that. Let me erase. Let me move forward. Into the new section. Yeah. Okay. I'm just going to have all of this up here as 1 and make it a little bit larger. Perfect. Okay. A complex number is in the form of a plus or minus bi. When I write plus or minus, it can be as a plus bi, a minus bi. Where a is the real part, the real number, and b is the imaginary number. And again, you can have, this is why these are called complex numbers. Okay? All right? So now we're going to deal with some of these situational problems. What to do if you see a negative inside a radical? Take it out and put an I in front of the radical. Now let's recall, I equals the square root of negative 1. Crucial information to recall. Okay? So we're dealing with the square root of negative 5. Same thing, we would separate this thing if we could. So we want to say negative 5. Excuse me. Let me rewrite that. It's all right. 5 times negative 1. Separate. Well, we know that this is I. So now we have 5, square root of 5 times I. The one thing that we need to understand is these will always go in front. The I does not go in the back. So the final answer will be I square root of 5. Just like that I comes out, any number that comes out, like we had the 12 before, recall we had this, and we had square root of 4 times square root of 3. Well, the 2 comes out front. That's what you do with anything that comes out. You put it out into the front. All right? So make sure we're good with that. All right, next one. Same thing. Separate perfect square, but it's got a negative. So if we say square root of 9 times the square root of negative 1, square root of 9 is equal to 3, square root of negative 1 is equal to I. In this scenario, this is technically positive and negative. This is technically positive and negative as well, because these are simplified ones. Now, it's not, when we get into these complex numbers, you won't make that positive negative. Won't make that positive negative. You have to follow the sign. So that's one of the little things that you're going to have to understand. It's going to take a little bit of time. It's going to take a little bit of practice, but you'll be fine. pull out here from me here, I want to separate this into three things. 4 times 3 times -1. And you'll notice I put that -1 in parentheses because I don't want it to get mixed up with the times signal. 4, 3, -1. What comes out? 2 square root of 3 I. If it's not inside the radical, it comes out front. Technically, positive and negative. It could be both. Just like when we're dealing with this is technically positive and negative. When we start graphing these, it's going to be imperative you understand the positive and negative. Here, it's determined that this is negative already. Okay? And we'll talk about, we're going to deal with this in a minute. I'm going to pull it up so I have a little bit of room. I want to make sure that we get a good image of this, take a little screenshot or whatever. This will help you. Okay? Before I start to move it up. Alrighty. Let me move. I gotta move. I don't like all these things. And there we go. All jumbled together. There we go. Cool. Because I need your total focus on this one. This is a little bit different. This is going to be a little bit tricky. Okay? First and foremost, when you have something like this, the first thing I want to do is separate this. -1. That's the first thing I want to do. I want to take that out. So now I have I 9/64. First things first. Sometimes this step is very, very difficult. Understanding to take that out first, particularly in this scenario. Now, the same way you can do this, the same reason you can do this, you can also do this. You can separate these things. If they're both under the square root, you can separate both of them. With that being said, then we have our I. Square root of 9 is 3. Square root of 64 is 8. How this would always be written is the I always goes after the number. Remember this, A plus or minus BI. So this is a number and this is imaginary, the I. Okay? So this could be rewritten and it's always going to be on top. So this could be written as positive and negative 3I/8. That is a tricky one. Tricky, tricky, tricky. Could you also write it like this? Yes, you can. That's fine. You just need to make sure that you stop that line and don't make it seem like the I is with the 8. Please understand that. The I is always going to be on top, at least for what we're dealing with now. So if you take it out initially, you'll see that. Take it out, then you're left with this, separate, simplify, put it back together, and go from there. It's like taking something apart, putting it back together. All right, here we go. A plus BI. Next one. So for this one, separate. 4 plus, I want to go -1 times 4 times 4. And I'm writing all of this out. Some of you guys are going to grasp this and won't have to do all of these.